Good morning, everyone. Welcome to our last matchmaking session of the year. My name is Samantha Agtarap, and I'm here today with Peter Love, the lead program manager of the lead program EIR for PowerNEXT program. Before we get started, I just want to express my gratitude and respect and acknowledge the lands on which Foresight operates. We are on the traditional, unceded, and ancestral territories of First Nation, Inuit, and Métis peoples. I'm coming today from the Coast Salish peoples in the lower mainland of BC. Our agenda today, we're going to start with this welcome and then some introductions. So, I also have a brief update just prior to the introductions on some programs that we have going on and other ones in other communities and other support areas that I wanted to introduce you to before we got into our presentation, because I think that we're going to have a very interesting discussion and didn't want to cut in at the end, so I'll start at the beginning. Our program is supported by IRAP, and we have 3 streams. We have this session, like industry matchmaking sessions. We also have the cohort program, and we also have strategic support. So if there's anybody on this call that has that is endorsed by IRAP and has an ITA, please reach out, and if you need help with certain things, we can look on how to get you assistance. The purpose of Foresight and PowerNEXT program is to help the world do more with less and sustainably, and connect the world's best clean tech ventures with industry to meet our overarching goal of Canada being the first G7 country to reach net zero. As I mentioned, IRAP is a support of this program, and they have this new program called AI Assist. I can add the link in the chat if anybody is interested, and you can learn more there. For the PowerNEXT program this year, or the 2024-2025 year, we've been focusing on energy storage, clean generation, smart grid, and today we're talking about the role of AI. All of these sessions are recorded, and you can watch them at your leisure. An upcoming challenge is the EcoNext Clean Energy Infrastructure Optimization Challenge. It's launching on February 4th. If people are interested, I think you can just Google that, or you can reach out to me and I can provide links. We're also looking for the applicants for the 2025 Clean Tech Awards, and there's a couple of categories: Venture of the Year, as a startup, Venture of the Year for Scale Up, Adopter of the Year, Clean Tech Supporter of the Year, and Funder of the Year. So if you know anybody or yourself, we encourage you to nominate, and it's open till February 20th. Self-nominations are encouraged. We also have partners at Emissions Reduction in Alberta, and I'm just sharing the Strategic Energy Management Program for Industry. It's called SEMI. It's about energy efficiency and reducing energy use in your venture. And there's a QR code on the screen, but or you can email the contact there, or also email me. That's it for sort of like the program updates, but I wanted to now turn it over to Peter to introduce our speakers.
Great, thanks very much, Sam, and we're delighted to. We've got some exceptionally talented speakers here today, and I'm just going to highlight some of their features. As you can see, we're going to start with Tommy Latte from Nokia, director of the Smart Microgrid Applied Research Team, and he's a seasoned software and digitalization professional who fights climate change and nature loss with data-driven industrial digitalization. So he's been very active with this and is an expert in data historian, analytics, and expert in AI solutions. And as you can see, he's a senior project manager at Nokia. And also joining us today is Stavros Sakinis, who leads the global business development and sales strategy for energy orchestration venture under Nokia's strategy and technology. He is exploring new adjunct business opportunities for Nokia in the power and utility industry, 20 years experience in the energy sector, and pioneering the commercialization of cutting-edge distributed energy. So we've got two presentations here, and we'll start with Tommy, and I think you've got present slides. We encourage people, put your questions in the chat as we go, and we'll respond to those, and there'll also be an opportunity at the end of the presentations to raise your hand and enter into a bit of a discussion. So with that, I'll turn it over.
I'll stop sharing so Tommy, you can share.
All right. And can you see our slides?
Yes.
Yes.
All right. So thanks for introduction, Peter. Small minor correction. So I'm a senior product manager for MIXI, Mission Critical Industrial Edge IIoT apps or industrial apps on Nokia's Edge platform. And then Stavros will discuss about energy ventures that we have also ongoing on Nokia. So agenda shortly. First, I'll go shortly why we want to put energy for or put effort on energy at Nokia. So we know that there is urgency for decarbonization, and especially my perspective from edge computing point of view is enablers how to harmonize data helps AI on edge and in cloud to how it supports these initiatives, and then Stavros has tells more about digital tools for smarter net zero and role of AI at Nokia. So shortly about this why. So we know that there is urgency for decarbonization, and we at Nokia we know this so that there is twinning energy with digital which needs to be done. And as our CEO Pekka Lundmark has well said that there is no green without digital, and this is like a high level guidance for us to make this happen. So in overall this energy or carbon reduction is not yet there where it should be, and one of the areas where we need acceleration is energy, and we need to foster energy transition with digitalization. And then how this is done is a topic what we will tell you today. So we know that currently there is a once in a lifetime transformation going on energy production via renewable energy, and then grids and other infrastructure must follow that and adapt to these changes. And we need many kind of solutions. For example, what I'm presenting with this Nokia's edge computing and collaborative intelligent agents for smart energy management from campus or real estate point of view is that how we enable flexibility of energy consumption for energy market. Then again to accelerate the adoption of renewable energy. And we know that we need scalability standards, ubiquitous connectivity, and AI at scale to make that happen. And very key element here is that how we get the data from different sources, what we want to control, so that we can have readily usable data for then this agentic AI and other controlling systems, which then balance the grid and balance the renewable energy production and consumption. And this is one big part of the puzzle when we want to make the solutions easily deployable and scalable and also replicable from site to site, so that we have to get rid of problems that currently there is in integrations of solutions on top of different energy sinks and sources. And now this harmonized data for AI from site and campus, real estate and so on It's now what we are studying currently with this collaborative intelligent agents for smart energy management project in Finland, where Nokia is one of the partners. I will tell a bit later more about that project, but where I come from Nokia Enterprise Campus Edge organization from Nokia. We build industrial solutions for industrial customers. So we are, you may know Nokia from mobile phones. So well, mobile networks is very core element on our offering, but it's we have shrinked it so that it fits to the edge computing platform, the network core, and then we can bring that network to, for example, the campus or manufacturing site or port or mine. And there is a private network then which covers the operations, and the data set stays on that site, or it can be connected to cloud capabilities also. So private 5G LTE Wi-Fi are our core products, what I'm representing here. Then what comes to this digitalization industry 4.0 promises and current pain points, we know that enterprises are not yet there where they would like to be with the industry 4.0 solutions. And there is many pain points, for example, data silos, connectivity, scalability of solutions, maintenance can be overwhelming, and then there is lock-ins for vendors and so on. So huge amount of blockers still to take all the benefits of Industry 4.0 and the promises that there is. And one key element here is that we have to separate data producers and consumers on edge level, but also in cloud. And smart IIoT edge applications or edge data ops is our solution for that. So we need to make the data really consumable already on edge, and then we can share the data to different purposes, for example, to smart energy management. And that's the overall view for that. So we have to have a scalable approach for data to make and integrations easily approachable, scalable way to that to make this acceleration really happen. And here you can see our typical environment. So there is, for example, factory where we deploy mission critical industrial edge. You can see in the center of the picture, and it's governed via Nokia Digital Automation Cloud in cloud environment. But the edge itself, it's on-prem at the site, close to the data sources, and that runs the private wireless network. It can run also Wi-Fi network and combinations of those, and there can be amount of assets and so on. But overall, we can connect these wireless data sources, but also fixed or wired data sources like PLCs to platform, and then make whatever we can imagine in the world on top of that platform with different capabilities. And on right side, you can see overall view to this our approach, what we want to achieve with data. So we need to have connectors to data. We have to have capabilities to stream the real-time data already on edge and make the data aggregation and harmonization so that it's easily approachable with different solutions. And then on top of that, we can utilize MLOps and possibly, for example, web scaler capabilities, and then, for example, system integrators, service providers can build then end user solutions on top of these capabilities for mining, manufacturing, wind farms, energy management, ports, mines, and so on. So this is our approach, how to make Industry 4.0 easily approachable, scalable, replicable, and thus accelerate the digitalization in general. And here you can see the overall view, Nokia mission critical industrial edge and in campus environment or in factory environment. So we call this approach Nokia One platform for industrial digitalization. So there is edge computing platform on site, always on site, which can run these private wireless and Wi-Fi networks, but we can deploy this platform also without private wireless connectivity. So if there is pure data computing need, so we can deploy this platform also for those to run some workloads on-prem environment. For example, if customer is not allowing data to flow to cloud. But we can connect this platform to basically any cloud, and then it's managed, governed via Nokia Digital Automation Cloud. And on shop floor or on front line level, there is our portfolio of industrial devices. Of course, we can also support other vendors' devices. Then there is this different end devices for private wireless and Wi-Fi network. And then there is this edge platform, mission critical industrial edge, aka MIXI, where we can deploy different apps for different purposes from our marketplace. So we have built this approach to make applications available on edge. And these applications can be then Nokia developed applications for edge computing, or they can be third-party applications which we have been partnered with. So for example, I'm representing two third-party application providers, for example, Litmus, which is famous currently rising industrial IoT platform or industrial data ops platform for industries, and then Crosser, which is very similar. Maybe a bit there is nuances between where biggest benefits of each applications come best around, but Crosser is another IoT application for our platform. Then this semantic data. So data in overall, there has been long time discussion about structured data, semantics, interoperability, and data models' importance for Industry 4.0. And now this standard-based approach for data is something that somehow we have to get it into use so that we can get rid of those very painful point-to-point integrations, which are tedious to maintain and then make solution replication very hard. And one very prominent model from manufacturing is OPC UA and its information modeling capabilities. So that gives an excellent approach for modeling the data from shop floor assets to edge platform, and then share this whole data model with populated real-time data to different applications which are using then the data. And basically also digital twin is a data model which then can be populated with the data and added some additional features like simulation, optimization, prediction, and visualization for that data model. So data model is very core element on Industry 4.0. And here you can see, sorry about this is a bit busy slide, but you can see here vision that we have for site level energy management. So we have edge data lake or message bus here on edge level. So that's what sits on mission critical industrial edge platform, and it connects to all kind of data sources. There can be proprietary protocols for that, but we can also take data directly in OPC UA. For example, in this collaborative intelligent agent for smart energy management project, we are demonstrating this approach in Nokia's new Oulu factory and Oulu site. So there is brand new site which will be ready during this year, and there is Schneider Electric's EBQ for building automation, for example. So we can get the data already in data models there. But then we have to connect different energy, like for example, electric vehicles, vehicle to grid parking lots and virtual power plant from Oulu Energia, which provides cooling and takes then the excess heat into district heating network and so on. So we need to get all the different data or energy solutions in this easily approachable way to this same data model or same harmonized model. And this is now big thing here, because if we can do this, then deploying different applications on top of that is very easy and straightforward. And for example, this energy digital twin is important part of this collaboration we are building in this project. And here you can see some results in this 2-year project, which started a couple of months ago. So we want to build scalable business models, AI and edge computing, and especially my point here is interoperability and data management, and then demonstrate possible outcomes in this project. So that's my part, and then I'll turn to the Stavros, and he will talk about sustainable energy management.
Great, thank you very much, Tommy. Hello, good afternoon, everyone. So delighted to be joining you all today. I'm going to share with you a little bit about what we're up to in our energy venture at Nokia, and have a bit of a conversation about AI in energy. So Peter's already introduced me, but I have only been at Nokia for 3 months. However, I have spent the past 20 years in energy, mainly in energy technologies. So hopefully I can bring some interesting perspective to this conversation today. So prior to Nokia, I spent 15 years at Centrica. If you don't know Centrica, they're a UK-based energy and services company, which under their British Gas brand have been the largest energy retailer in the UK for over 200 years. So that's where I've cut my teeth. I wouldn't consider myself a technologist or indeed an AI expert, but I've kind of learned through trial and error, failing fast, timing, and a bit of luck, how to kind of cross that chasm in bringing new technology to energy, which is a complex industry. So I suppose what's an energy guy doing at Nokia? So that we've set up a new venture under our technology and strategy division with an aim of building new digital tools for a smarter net zero. So Tommy's driving my slides today. So next one, please. Thank you. So our vision is simply, we're looking to enable resilient, green and affordable power through digitization. We've got a new energy focus. So we see kind of decarbonized distributed electrification now as being the most cost-effective way to run the world's economies. And kind of managing this new system, this new paradigm really requires new technology and new ideas. So we are spun out of Nokia Bell Labs. So we're kind of leveraging our 100-year heritage of award-winning innovation, with an aspiration to really invent the future of energy. Our ventures really focused on 2 kind of key capabilities. One is digital twin, which Tommy alluded to earlier. And the second is the advanced orchestration of energy flexibility. So those are the kind of 2 themes we're focused on. And we think the time for both those capabilities is now, because quite frankly, the energy landscape has changed. Let's go next. So look, energy has changed. I've been in the industry for quite a while, and those who have also been in the industry, you might kind of resonate with this. It feels like innovation in energy moves really fast, but at the same time feels incredibly slow and can be very kind of regulatorily heavy. But look, having spent a while in this industry, I feel pretty confident saying it has changed now, and certainly the way we manage the energy system has changed. It is becoming decarbonized, distributed, decentralized and demand-driven, and digital. Let's go next. So the energy system, it is becoming increasingly decarbonized. I think we can all argue that potentially not decarbonized enough. But I would say it's becoming decarbonized enough to impact the way the system is managed. So renewable energy accounted for 29.1% of global electricity production in 2022, and that's up 18.3% from 2000. And solar and wind has gone from almost zero 2 decades ago to over 12% in the global electricity mix. So look, electricity and energy is becoming decarbonized. Next. It's also becoming more distributed. A lot of this renewable energy is distributed energy, and that penetration of distributed renewables is expected to continue as the world kind of continues to race to meet net zero targets. So again, we're probably behind where we need to be, but the penetration of distributed renewables is expected to increase from 4,000 gigawatts in 2023 to over 7,000 in 2028. So again, we could and should be doing more, but the energy system is definitely becoming more distributed. Let's go next. So energy is also becoming, decentralized and demand driven, and that energy demand is really growing and it's changing shape. And that's driven by two key factors I want to highlight. So the first is the electrification of heat and transport. Now, this is kind of was predicted, and it's planned into grid operators' long-term infrastructure plans. It's something that's been foreseen, and it's largely been driven by regulation, but now also innovation with the falling battery costs. So you can see EVs in particular, 18% new cars sold in 2023 were electric. By no means the majority, but certainly enough to drive that change in the way the energy system works. And the second point is one that kind of wasn't planned for, and that's data center demand. And very topical for today, that's the recent kind of explosion of AI has driven a much faster than expected increase in load growth from data centers around the world. So Goldman Sachs estimates that data center power demand will grow 160% by 2030. And some of the news yesterday, what's going on in the US, that may accelerate further. So look, demand is becoming decentralized. So the energy system is becoming decentralized, it's becoming demand driven, and that shape of demand is changing quite substantially. And look, maybe most relevant for this audience and the conversation today, energy is also becoming digitalized. So if we look at the kind of mega trends that are happening and over the next 10 years, I want to highlight three. So one is connected everything. So we've already got 7 billion devices, connected devices in people's homes around the world today. And the annual market for smart home is set to increase by 5 times to 2032, reaching a $500 billion a year market. So connected everything is accelerating. Second theme is digital twins. So digital twins and virtual power plants are now being integrated into the entire energy value chain. And the market for digital twins is expected to grow at nearly 40% compound annual growth rate to 2030. Last theme, again, most relevant today, is AI. So AI will enhance and automate decision making for power plants, grids, and the whole kind of energy value chain. And we can kind of see, some of the impacts in AI, some of the changes in a future workforce. So Gen AI has the potential to automate work activities, 60 to 70% of employees' time. So look, I think there's no doubt that AI is bringing and will bring incremental and transformative innovation to the energy sector. Let's go next. And that gives some big questions. So in a future of connected, communicating, and intelligent everything, could we use AI to automate the entire energy system? And obviously, if you go down that route, you've got the question, should we? There's regulatory privacy implications, technology, and acceptability. So energy system is massively changing, and it's raising some interesting questions going forward. So let's go next. So we think energy has changed. And there is also now an accelerating need for a step change in approach of how we manage the energy system. So we need new tools to plan, optimize, and dispatch a highly distributed energy system. And this kind of need is being felt across the entire value chain. So if we look at network operators, they are needing to adapt faster than they were previously expecting to digital alternatives to traditional network reinforcement. So they need new digital solutions to either defer or avoid that network reinforcement and avoid passing on, enormous costs to end users of upgrading the grid. You've got system operators. So system operators are around the world. We're seeing a trend moving more towards localized energy balancing and more real-time balancing of the energy system. And that's kind of driving that growth again for virtual power plants, digital twins, and microgrids. Finally, and last but not least, at the other end of the value chain, you've got the consumers, the prosumers. So consumers, businesses, homes and businesses at the end of the meter can now actually play an active part in the energy system, but many of them still lack the technology or the resources to maximize the value of energy assets and devices, whether it be in homes and businesses, and what the flexibility of those devices can bring to the energy system. So look, there's a massive need for a change in approach in how to manage the energy system. Let's go next. And look, that's why at Nokia Sustainable Energy Management, we are building new digital tools to simulate and optimize real-time flexibility of energy systems. So the platform we're developing, we're a new venture. We're developing two core components that are kind of intertwined. The first is we have our digital twin simulator, and that's coupled with an energy orchestration and optimization engine. So let's go next. And our platform, is based on an innovative methodology. So we've taken ideas and technologies pioneered at Nokia Bell Labs from real-time telecommunications applications, and we've applied them to the energy system. So our platform can build, increasingly complex digital twins with nested logical orchestration nodes, and those nodes can be located anywhere in the value chain, whether physical meters or commercial kind of entities doing the optimization. And using our platform, users can undertake user-defined optimization. 1 second, I've lost you. There we go. So look, users can undertake their own user-defined optimization and simulations, scenario modeling, and they can do that at a fraction of the time that it would traditionally take. So the idea is our digital twins are then deployed into real-world energy systems, leveraging the simulation orchestration engine and optimizing at each node level. And the way we've kind of designed this platform is the innovative methodology gives us speed, efficiency, and kind of massive scalability. So that's the platform we're building in our new venture. So topic of today, where does AI come in? Let's go next. So it may be somewhat surprising, we're a new venture building new technology. So it might be surprising to hear that our software doesn't actually use AI directly in its architecture. Our technology focuses on real-time optimization of data streams as opposed to, analyzing, or forecasting very large amounts of data. But as with many systems, it's, we're ready and compatible to harness the massive benefits that the future of AI will bring. And I kind of wanted to touch on 6 points where we feel AI will have a massive augmenting impact of the systems we're developing, and that can apply to other systems as well. So number one, as we see a changing workforce, the rise of digital agents and an AI enhanced workforce, we see a more seamless integration with digital twin simulation, and then autonomous orchestration of energy systems. Number two, we see AI-enabled intelligent market trading, particularly energy market trading, delivering kind of more complex real-time energy procurement. And then that interface with intelligent orchestration will drive more value through the energy value chain all the way to the end user. The next application of AI is, within our platform I showed earlier, we have, nested orchestration nodes, and we see the application of AI allowing those nodes to become more intelligent, more autonomous in their decision making, particularly when applied in real world scenarios, undertaking more complex optimization orchestration on larger distributed energy systems. So number 4, one of the big challenges that Tommy touched on as well is system integration. So we see our platform, like I see platforms in energy today, the way they're going to succeed is being part of an ecosystem with other platforms. So in our case, whether an orchestrator sits on top of a DERMS platform, or we're simulating into a grid energy management or energy management piece of software, we see our platform and others existing as an ecosystem. And we really see AI's potential to automate that system integration and do something much faster that traditionally system integration is a huge drain on organization and takes a lot of time. So yeah, we see AI really helping with that system integration. The next point is machine learning enabled forecasting. So whether that be weather, whether that be markets, behavior, state of charge of a fleet of EVs, we see that machine learning enabled forecasting really helping to create better digital twins and then better implementation of real world energy orchestration. And then kind of the final one for me, one of the greatest real world challenges, if you can't connect to it, you can't orchestrate it, and you certainly can't optimize it. So we actually see a huge potential for AI to enable that seamless and intelligent device and asset discovery, connectivity, and that being one of the keys to deploying intelligent energy orchestration across the energy system in the real world. So I suppose, look, our platform isn't built using AI, but it's certainly, as many, going to be totally augmented by the advances in AI. So we're kind of ready, and we're ready to unlock the potential that AI can bring to a changed energy system. So let's go next. So kind of last slide. So on that note, look, I'd like to really thank you all very much for your attention. If you like what you've heard, we'd love to hear from you and explore opportunities for collaboration. And we are a new early venture in Nokia, so we are keen and open to collaborating with potential customers of our platform, particularly in this early stage. So we have a front runner program, and we want to work with customers and build our simulation and orchestration to really suit our customers' needs. We are looking for potential partners, so whether it be a partner on a customer project, an innovation project, or an exploratory deployment. And then finally, as an investor, as our venture grows and expands potentially beyond the virtual walls of Nokia. So look, would love to collaborate with you if you like what you hear. So with that, thank you very much. And I think passing back to Peter.
All right. Well, thank you very much, Stavros and Tony. Tommy, great amount of information there. And we've got one question, and we'll get to that. And I encourage you, those others on the line, if you've got questions, please post them or put your hand up. I just will comment, just it was in the paper this morning, as we all know, Donald Trump's been very busy doing a lot of different things. But among the more interesting ones, it was reported this morning that the U.S. is to invest up to $500 billion, that's B with a billion, in data centers and electricity generation needed for AI. So and so this isn't an idea. This is they have got together with a bank in the U.S. and they're looking to roll this out. So not surprising. This is huge money. They don't mention Elon Musk, but I'm sure he's part of this drive as well to use AI. And of course, one of the things they want to do is reduce the number of federal employees. So sounds really interesting. So let's go. We have our first question. Again, I encourage you to post them in the chat or put up your hand, and Sam can see you. So this is from Anna Mani. And she's the director at Polonovia Technology. We offer a cost-free AI-controlled sustainable heat energy system. However, large companies like Google and Amazon seem hesitant to adopt it due to cybersecurity concerns. What approach does Nokia take, and what are the future solutions to address this issue? Great question, Anna. Thank you.
So if I start from my point of view and edge computing point of view, of course, yes, cybersecurity in every business is critical, and we address that so that we are partnering with these cybersecurity providers, so we can onboard those cybersecurity applications to secure this edge platform. For example, Palo Alto, Zscaler, and so on are in our catalog. But then on the other hand, this secures the platform, but then there is many things like access control and so on, and also data in move. And then OPC UA actually is protocol which has inbuilt security features, pretty much same level than what in typical IT applications have. So there is solutions; those just need to be taken into use. That's my view to that. And then Stavros, if you have.
Yeah, maybe give a perspective on that. So look, cybersecurity obviously extremely important and extremely important to large companies, and maybe a bit of experience that I've had in the past, both at Nokia and before, actually working with startup companies or earlier stage companies like yourselves. So obviously big customers can be very risk averse to the point that it stifles innovation. And I suppose maybe slight shortcuts or slight techniques I've used in the past, either with third-party suppliers or when I've been doing ventures to kind of mitigate some of those concerns, is I would propose kind of starting small. And the risk is of course important, but if you can limit, whether it be a trial or your first set of customers, if you're trying to prove a new concept of technology, and sometimes agree a path with those larger customers on, right, how you're going to start, how you're going to limit the risk, and then grow. You can sometimes work with the cybersecurity departments or procurement departments on a path to getting your solution adopted at large scale. But look, it's challenging. It's an incredibly important and sensitive topic, particularly the bigger the customer or potential customer goes.
Good. All right. And any follow-up question, or is that you happy with that? Okay, I'll move on to the next question from Tanner. Would love to connect and discuss how we can collaborate. What's the best way to get in touch?
Yes, I don't know if we're sharing kind of contact details directly, but maybe if you contact Foresight, and I'm kind of happy to share my contact details. We're looking to collaborate, so certainly would like to hear from you.
Okay. Yeah, Sam.
Yeah, people can email me and I will connect them directly with Tommy and Stavros.
Okay, great. And Patrick Marshall asks, does Nokia work over Siemens and Schneider controls?
Well, this is now maybe to me at least first I can start. So we are looking for overall compute. So what is the this like an additional capabilities with data-driven capabilities for edge? And so assumption is always when I talk is that there is, for example, existing control systems or basic building automation on plant already. So there is these Siemens and other vendors who provide those, and then we can connect to those, connect, collect, aggregate, and harmonize the data on top of that, and also add additional sensor systems to that picture, so that we can build this overall harmonized data layer on top of that. And this is the way I see the value on edge computing and edge data hub, especially for edge AI, because the more advanced AI you want to deploy, the better condition your data must be. So structured semantic information with metadata is like a precondition, for example, for AI agents or Gen AI to be usable in future. Currently, there is no actually this kind of at least commercial solutions for edge computing, but this also applies for any data, which it's best to put data in good shape already where it born. So edge is very great environment for that. So make the data already consumable on edge where it borns, and then you can share and utilize data for different purposes through the data lifecycle.
Great.
I think that question probably was more at Tommy, but maybe to kind of chip in from our
Yeah.
sustainable energy management venture perspective. So we
All right,
are.
sorry.
I don't know. I'm sure it was definitely you, Tommy. But in the way we're kind of thinking about edge is like, look, the orchestration logic. If you've got an orchestrated energy system, the further towards the device and asset you can put that logic, the more you can optimize an energy system or virtual power plant. So we're certainly looking at deploying that kind of node logic at the edge and working with as many manufacturers as we can when we go to real world deployment.
Okay. And I just want to do a bit of a time check here. Tommy and Stavros, are you able to continue to talk with us for another 20 minutes, 30 minutes?
Yeah, I can probably do 20 minutes. Yeah.
20 minutes?
Yes.
Okay, great. So we've got a bit of time. Any further question? I don't see anything in Outlook or in the chat. What we thought we might do is if I could ask people on the line, especially those of you who have not asked a question yet, maybe just very briefly introduce yourself, less than 30 seconds, and maybe just give a comment about the thing that interests you in AI as it relates to your venture. So Sam, do you want to maybe call people and let them know who the next person up is?
Sure, I can do that. I'm just gonna go down the list. We've heard briefly from Anna, so I'm gonna come back to you, but I'm gonna start with Ben at Elastic.
Hello there.
Hi,
Sorry, just
Ben.
making
Go
sure I'm
ahead.
getting my getting this on here. Sorry, I missed the preamble there.
Just a 30-second intro, and if you want to, how does this relate to your business?
Yeah, of course. So at Elastic, we're working on kind of the final layer in the home. So we have all of these. Every home more and more is getting all of these distributed devices, and they each need, like Stavros mentioned, they each need control and intelligence around how they're going to use energy. And Elastic is building that kind of final layer at the home to help aggregate all these edge devices into in the home into essentially one black box of energy that interacts with the grid. So kind of the final congestion point or collection point of the home onto the grid is the meter. And so within that black box is a whole lot of optimization that can happen. And so that's the core tech that we're working on.
Thanks, Ben. Did you have a question you wanted to ask, or you're good for now?
My biggest question for the Nokia team is where do they see the logic for V2G resting, the decision-making process, and where do they see that being most impactful?
Yeah, maybe so V2G is a big topic. I mean, my experience, I'll tell you previous life. So at Centrica, we launched some of the first smart charging energy retail tariffs. So that was something that my team did. And those retail tariffs included direct control of cars. And it wasn't V2G, V1G, whatever you call it, but it was basically stop, start, charge. So you've got an evolution, you've got stop, start, charge, and then you have vehicles that then export back to the home and then net export to the grid. So that's kind of how I see the journey. And really the driver for when you stop start the charge of a car or when you start exporting to the home, you can actually have multiple drivers. So I'll give you some examples of how I've seen it in the past. So if you're an energy retailer, you want to reduce your wholesale cost of energy, reduce your demand charges, and reduce your imbalance. So you can put out pricing signals to those customers, and within the customers' availability to stop start their charge, they might say I'm free for overnight, then you can stop start based on those pricing signals. So to your point, the signals come from a few different places. So you can have a pricing signal in retail, you can have the transmission system operator or DSO, looking for flexibility services and either dispatching those or having those react with, if it's a frequency response service, it'll react with local metrology. And then you've got kind of customer preferences and what's happening in the home. Has it got solar? So that logic can come from a bunch of different places. So, the space you're working on is super interesting because ultimately, who makes the decision should be the customer. Where do the signals come from? Well, they can come from a lot of different places. Actually, the more the better, because that value stack can give the most value back to the customer and the energy system. And that's where, software that you're working on and we're working on is important, because it kind of acts as that intelligent, brain. What is the best way to deploy this device at the end of the meter, at the end of the customer's house? So that's kind of my perspective. It's a fascinating space. It's still kind of evolving. Whether we get to vehicle to grid, I don't know. It's expensive, but certainly EVs, the flexibility in EVs is a huge resource for system operators and people who own them.
Right.
Very cool.
So we got a few more people we want to introduce here. Sam, who do you want to call on next?
I've got a list, but in terms of questions, let's go to Mujtaba, and if you could just introduce yourself and your question, and I apologize if I pronounce your name wrong.
No worries at all, Sam. Hey guys, pleasure to meet you. My name is Mujtaba. I'm building an energy tech startup. What we do is we build data centers here in Ontario, Canada, to monetize some of that surplus renewable energy. Similar goals as you guys, really getting flexibility into the demand side of the grid system. So my question here for you folks is, so you've noted a couple of times that the grid system is currently evolving and managing this grid system is becoming more complex and digitalized. So could you just explain a little bit how your solution that you presented here kind of solves that problem? And one of the questions I constantly get from my mentor is, are there any other ways to do this? And why do we want to go with yours?
Yeah, I can take a stab at that. Maybe if I talk specifically to data centers, look, you're in a really fascinating space right now. And from what I've seen of data centers, there's a couple of challenges on the energy system. One, especially if you look at Project Stargate, I think it was called, that was announced yesterday, like the amount of data centers trying to connect to the energy system, particularly in North America, one of the big challenges getting network connections. So the grid just does not have a bunch of spare ports, etc., to connect these data centers. Some of them are in, excuse the oversimplification, but kind of middle of nowhere without any energy infrastructure or generation. So you've got to think about, and I'm sure you probably know more than I, but if you're connecting a data center from scratch, you need to get the connection from the network. You also need to make sure that data center can be powered as cheaply as possible. So where our solution kind of plays a role, so we've got the digital twin aspect. So we are talking to grid operators about creating digital twins of their parts of the network where they're looking to create data centers, and modeling how they can accommodate that new connection in the lowest cost way, or how they can accommodate matching that data center load with renewable energy sources, or indeed some of these data centers are coming with their own proposals for new generation. So there's that kind of undertaking that digital twin simulation alongside the flexibility can really unlock the connection in the first place. And then when the data center is up and running, I mean, this sounds like what you guys are doing, but really optimizing the way that runs going forward. So we see that being part of our orchestrator capability. And how does that data center and its flexibility also interact with other flexible resources on the system? So yeah, that's hopefully that kind of gives a little bit of perspective on your question.
Right. All right, Sam, who do we have next?
Next, we have Chris from Green Label. Introduce yourself, Chris, and then question. I don't know if Chris is able to join us, so I'll just ask his question. Chris says, jump in, Chris, if you can. Chris is with Green Label, and Green Label is looking at AI use for highly distributed VPP management and billing from multiple sources in BC. We are looking at Starlink for remote data access and management, but digital twinning and local charging systems are tricky. I don't know if that's so much a question or.
Yeah, I don't know where the question was there.
Okay, sorry, Chris.
Agreed.
Follow up is says there. The question was about consistent data. How do you? He has audio voice issues right now. So
Yeah,
like how can you get consistent data from a system?
I suppose I'll give my perspective, and then maybe Tommy can give a perspective, because the Mixi platform is, a more commercialized real world applications. But yeah, I mean, data is always a challenge. Consistent data is always a challenge. If we're talking about flexibility and orchestration, the data required is normally dictated by whoever's running the DR programs or the grid operator who's running the ancillary services. So making sure you get the data, getting the quality of data, but also meeting whatever the grid operator needs is hugely important. Especially if you start running into more real-time services like frequency response, you need second, potentially sub-second data, which these days it's not overly checked. It's just assumed you're delivering. But in future, if we come to more real-time orchestration, you'll need that kind of volume of data. So I don't know if that gives an answer or perspective. Maybe Tommy, if he has a perspective on that one.
Chris from Green Label says Green Label is looking at AI use for highly distributed VPP management and billing from multiple sources in BC. We are looking at Starlink for remote access data and management, but digital twinning and local charging systems are tricky, and the use case is remote EV chargers.
Well, from my point of view, I'm looking for overall data harmonization. So I don't have actually give or information for that question, but I see that whatever is the subsystem we want in part of the energy optimization or flexibility in site level or local level, we have to somehow make the data readily consumable, and so basically data models and harmonization is the key for that. But unfortunately, for we have in this Oulu demonstration we are building during this year, there is EV charging station and vehicle to grid option also. So we are waiting that we can get some experience from that. So it's one part of the energy palette we have, and then there is VPP, and then there is building automation and solar panels on top of the campus, and then of course grid connection and district heating connection for surplus heat. So this is our and overall this whole site will be net zero for carbon emissions, for example. So all the electricity we use in testing and in facilities, also excess, it transforms the there is huge amount of labs, so electricity is transformed to heat, which is then taken to local district heating network. So this is what we will demonstrate in this CSM project, and build a local optimization for flexibility market point of view for that.
Thank you.
Maybe I've just had a question, so apologies. I wanted to give a bit more of an answer because I don't think I gave a good enough response. I just clocked that it's, the challenge here is remote data from remote chargers. And, I see that can be quite challenging. I suppose one point, I think a lot of people here are in early stage ventures, but an important thing is timing. So getting remote data from remote chargers is likely expensive, and now will probably, I'm assuming, eat away at any benefit from managing the flexibility on that charger. So I think one important thing is to understand that business case of how much is it going to cost to get that data versus the benefit now, and then think about the timing of when that's going to be commercially viable. Because if it's not commercially viable now, that doesn't mean don't do it. It just means you kind of have to think about the timing of when it might be relevant in future. So I wanted to add that. I don't know if that was helpful, but I just clocked the question. So
Thank you. No further updates from Chris in the chat. So I hope we I hope I accurately conveyed his question, and I thank you for the answer. I'm going to go next to Olu. If you'd like to just introduce yourself, and then you can ask your question.
Everyone, my name is Olufo. We're from Tap and Go EV in Vancouver, Canada. Yeah. I think maybe part of my question must have been answered in the last question. We also manufacture EV chargers, and then we're looking at exploring our database to gather insights for artificial intelligence, and I think we've been discussing IoT devices. Okay, and I'm thinking, okay, how do we get that to work with the chargers? Okay, do we embed them? Okay, do we need to really think our product lines? How do we see this working?
Yeah, so I mean, maybe I'll go first and then Tommy chip in. I mean, my experience with EV chargers is it's kind of one of the few device types, small device types, that has got some standard communication. So you've got the OCPP communication standard and protocol. And in my experience, although it's fantastic to have standards in real world, what I found previously is they're not always implemented in the same way. So I would kind of my guys would stick to the standards, but there's always going to be some variance on how they're implemented by manufacturer. But those standards, we found that OCPP allowed us to communicate with the charger sufficiently enough to do stop-start charging for retail optimization. And I'm not an expert on the standards, but I think they're evolving to allow for more real-time communication for EV chargers to do more, whether that's moving more towards frequency response type real-time or vehicle to grid. So yeah, not an expert on the detail, but EVs fortunately have some standards, and yeah, we look at implementing those, and they're the kind of standards that most aggregators, energy retailers, and charge point management companies tend to use, from my experience.
Sure. Hey everyone, my name is Kelly. I'm one of the co-founders at Liquid Energy. We are a pretty early stage venture as well. We build solar powered off-grid edge data centers for specifically AI inference test time computing. And I don't have any questions specifically, but I'd also sort of love to connect with Tommy and Stavros afterwards to see if there's any opportunities or overlapping interest areas.
Great, thank you.
Thanks, Kelly. I'm going to go next to Taylor.
I work with Olu at Tap and Go EV as a software developer. I don't have any specific questions either.
Great.
Nice to meet you all.
Thank you.
Thanks, Taylor.
First of all, hi, I'm Anna. So I am the director of technology innovation and climate action development with Halinova Technology. We have several subsidiaries. Like when Olu and Taylor actually is one of working for one of our subsidiaries that they're mainly in EV charging station ecosystem and development. And Seno is a business analyst that works for Halinova Technology.
Okay. Thanks, Anna. Brian, did you want to introduce yourself?
Hi, my name is Brian. Right now is that I'm the input and distributed EV charger, and is that we have a concept is some solar power, is a wind power, and is that the ESS system. First is the EV charging system right now, but it is just the right now concept. Is if next time is I have a chance is I will ask, and is I will request this advice that one. Thank you.
Yeah, thank you.
Thanks, Brian. I think I've gotten everything, but as Patrick, you turned your camera on. I can't remember if you had a chance to introduce yourself.
No, I didn't. I'm Patrick Marshall. I'm a co-founder at Swordfish Energy. We're an edge device. And in working with focusing on decentralized autonomous energy, not grid. So it's coastal energy. We're a next iteration in design from most of the screws. I'm interested in Nokia because over the last 20 months of exploring relationships with Siemens and Schneider, I'm not connected with the right people yet. That's why I asked the question. And I'm just starting to understand the AI, because our systems, we have an opportunity for 250 installations across Canada's Pacific before we go to the Arctic and the Maritimes. So these need to be networked. And it seems, I love the presentation. Thank you, Foresight. It's not something that I would normally get to see. So I'm looking forward to sharing this with my founder, who is an industrial designer, not an engineer. And so if I could understand it, he will understand it. Thank you.
Good. Okay, Sam, is that about, have we been through everybody?
I think so. If there's anybody that I didn't call in, I apologize. You could just unmute yourself and or turn your camera on, and this is a chance to ask any questions, final chance to ask any questions and introduce yourself and your venture.
Hey, Tanner Barron here from Edgecom Energy. I dropped a message in the chat. Would love to connect with the Nokia team. At a super high level, we're an IoT and AI energy management firm based in Toronto. So our platform serves as the connecting piece between, internal data that we're able to collect within mainly mid-sized manufacturers, and then plugging those into different opportunities on the grid side of things, whether it's grid interactivity, price, peak avoidance, emission avoidance, all that fun stuff. So general kind of points of benefit there: reduce cost, emissions, and downtime. We're deployed in 180 facilities across North America so far. But I think there's a lot of synergies in terms of what the Nokia team is working on and what we've already kind of pushed forward and have deployed within some of the facilities that we're supporting. So I'd love to.
A number of you said you would like to be in touch with them. So what I might suggest is that you send an email to Sam and maybe briefly summarize for Nokia what it is you're doing and what you think the opportunity for partnership or collaboration might be. And then Sam will forward it to Stavros and Tommy. So I think we'll bring this to a close. We want to thank everybody. I want to thank especially Tommy and Stavros. Very detailed presentation. Obviously, you guys are real leaders in this. You've sparked some real interest among our ventures, which is great. And we'll hope to that this will lead to some collaboration. So thank you very much for your time. And Sam, any final comments?
No, I mean, the only slide I had left was my email, but I just put it in the chat. I hope I put it in the chat. And if you have any questions, please email me, or if you want to be connected with our presenters, let me know. And I just want to extend my gratitude for the presenters for being here. I know the time change. I'm on the west coast of Canada, and Stavros, I think you're in the US.
I'm East Coast.
East,
yeah, I'm Philly.
and then Tommy, you're in Finland, I'm assuming.
Yes.
So
It's
we're
evening
all
time here. Yeah.
Thank you very much for making time in your day for us. I really appreciate it, and I look forward to future opportunities. Thanks everyone for being here, and we'll see you next time.